Okay, are you ready, Danai?
Yeah.
Okay. Well, thank you everyone for attending today. We are going to do, together with, Canadian Solar is going to do a presentation on optimizing your design with east-west racking on flat roofs and how Canadian solar panels are well suited for that. Danai is going to do the presentation. She is from Canadian Solar. And if you do have questions, we ask you to use the chat function in this app. Just ask your questions in here, and we will answer them as they come up. Danai, if you're ready, take it from here.
Yeah, thank you for the intro. So this is a short informational session as a follow-up to Frank and Solar's previous webinar with SL racking, where they were describing how you can optimize your design racking wise with using east-west facing configuration instead of a south-facing one. And where I'm coming in today is to show how that kind of setup can be combined with our module, the 6.2 66 TBH, which Franken Solar has in stock at 620 watt power, and to essentially maximize the yields of that setup. So this is a standard CNI format module. It is at 2382 by 1134. It has a 40 millimeter frame, which in part adds to its very high mechanical allowances. So we're going to see how that plays out in the next slide. And it has some really good electrical characteristics. So again, we are going to delve into that a little bit further, but what is useful to keep in mind is that for the 620 watt power bin, it has an open circuit voltage of 48.4 volts. And how we keep that lower than maybe some 182 by 182 wafer modules of the same format, or some 182 by 182, is by having a larger wafer. So this one has what we have coined the 182 Pro wafer size, which essentially is just a 182 by 210. Now, because of its construction, double glass, very thick frame, it can support very high mechanical allowances. Now, it's compatible across number of different mounting configurations, including fixed racking and tracker. But what we see being used the most is this 4-point clamp mounting with 2 rails running parallel to the short side of the module. So with that configuration, you can get up to 5,400 Pascal downforce and 4,000 Pascal uplift. Now, if you want to go very extra and add a 3rd rail, which I know no one's really a fan of, we can reach some even higher mechanical allowances. And where you see a lot of the difference here is in the uplift. Now, that's something that we don't really see as necessary in Canada. We deal with that sort of requirement sometimes in the US when we're dealing with, I don't know, South Florida or something. But for the most part, you'll be covered by this first configuration that I've highlighted. Now, moving on to the electrical parameters, I mentioned that because of the wafer size, we're able to drop the VOC. Now, by dropping the VOC, when you're doing your string calculations, what we found is that you're able to fit an extra 2 modules per string when, let's say, in comparison with any other 182 by 182 millimeter wafer. Now,
that's in 1500 volt application, right?
Yes. Yes, with commercial, with CNI, I think most of us are used to working with that.
Yeah, in Canada, you can do 1500 volt on rooftop. I don't think you can in the US, but in Canada, you can do 1500 on rooftop.
Yeah, I'm not sure. US and solar, the regulations are sort of constantly changing and not always for the best, but Canada is a good leading partner in the industry for sure.
Yeah.
But the point remains that, especially in those CNI or utility applications, if you want to sort of utilize to the best of your ability both the labor around the installation site and the materials that you're going to be needing, it is a big advantage to be able to fit more modules per string. And whatever savings you have per string, depending on the scale of your installation, is just going to keep building upon itself. Now, if you have another way to maximize the modules on your roof, let's say by using east-west racking, um, that works in very good synergy with your ability to fit more modules per string. So these are some layouts borrowed from SL Rack, who did the main webinar, let's say, on this topic. But what they keep finding is that you're able to maximize the space on your roof much better by not having to create those in between road distances. So in this smaller roof, from 12 modules with a north-south direction, you're able to go to 18 modules, increasing your system size by 50%. Now, this also translates well in a utility application where you're able to increase your system size by 30% and go from 704 modules in this left photo to 914. Now, there are also some inherent, let's say, benefits to east-west racking. So pure parts, pure steps. You don't really need as much ballast handling, and you don't need any wind guards. So that is a huge advantage on the racking side. Now,
Yeah, Denai, if I can jump in quickly,
absolutely.
you know, from the racking side, if you're looking at how it's designed, it's much more aerodynamic to go east-west versus south-facing because you don't have any sharp edges. Like, you know, when you have a south-facing panel and then a wind guard in the back that is at a 90-degree north-south, up-down, so nowhere the wind can grab. So, and then specifically the SL rack is very close to the roof as well. So very little uplift forces, which really helps with lowering the ballast of this racking and panel combination. Together with the Canadian solar panel that is super strong as far as, I guess, what is it called? Down weight, snow
The snow load is very good on these
snow
models.
loads is extremely high, right? So you're really well situated with this combo.
Yeah, and again, this is just a follow-up conversation on the racking. I believe the full webinar from SLRack is available, and we do see this configuration making more and more sense to customers, and it's something that's being widely adopted in Canada. In part, I believe, because of some recent legislation changes too that we can go into during this FAQ that I
Yeah,
brought.
I think, you know, if I can quickly jump in further, if you can go back to the last slide. Obviously there's a significant amount of extra modules you can fit on a roof. And if you would have talked to me 6 years ago, you know, I would have said that's not a good idea because your solar panels cost a lot. But now solar panel prices have come down drastically, especially in anywhere but the US. Solar panel are extremely economical and no longer the most expensive part of the system. Now most of the money is spent on labor and, you know, things and things like that. So with panel prices where they are, east-west racking makes a lot of sense. As Danai already kind of mentioned, you need less components as well, no wind guards, which is a major cost driver, for example, for racking. So you really bring down your racking costs. And at the end of the day, what we're trying to produce here is the lowest levelized cost of electricity, which, if you do the math, east-west racking will provide you with the cheapest cost per kilowatt hour produced.
Yeah, and it's again, when we're talking per module or per kilowatt hour, those racking costs do go down a good amount, and the labor costs go down with them because of the fewer components used. And with Canadian Solar specifically, because of that wafer size, the labor costs also go down because you can string more modules per string. Now, Ed did help me come up with a Q&A section on, let's say, some frequently asked questions, that customers that are interested in East-West configurations typically have. So, the first question is how east-west racking helps production. And essentially, because of the way it's facing, the sun gets to hit it a good amount earlier than it would if it had to wait for it to be in south position or south-facing friendly position. So that creates a longer but flatter production curve, as we see on this picture here. Now, even though the area of these two might be very similar, especially those customers who, let's say, maybe have a battery added to their system or are interested in being able to directly consume the PV power that they're producing with or without battery, having that extra length of time is a good advantage. So right now, we're all a little nervous about electricity prices. And just drawing from a personal example, my sister's in the Netherlands and they're seeing some wild fluctuations over there with price per kilowatt hour. And they mostly see it in the evening because that's when they're not producing from the very robust PV backup of the grid that they have implemented throughout the years. So for the average consumer, having that extra, let's say, hour and a half window in the morning and an extra hour and a half window at night, that gives them this added resiliency that has always been a selling point of modules and solar in general. So essentially, you're waking up your system earlier and letting it go to sleep a good amount later.
Yeah, and if I can add to that, like if, for example, Ontario, which has time of use, if you look at what electricity rates are and when they're at the highest, it's usually weekdays, early to mid morning, and evenings, like late afternoons into the evening, is when the electricity prices are the highest. And if you have self-consumption, this obviously makes a lot of sense.
Yeah, 100%. Now, some other costs that can help be alleviated is through all of the racking components that we talked about. So not nearly as much ballast, no wind guards required, and the overall racking cost per module dropping. Now, I did make a brief mention to some changes in legislation, and Ed or Danny can help me verbalize that point maybe in a little bit more detail. But from my understanding, due to some recent building changes or building code changes in Canada, PV arrays of a certain height become really restrictive. So by not having as much ballast on the system, you don't have this this height adder to your array across the board. So that's another way that East-West helps bring more rooftops under this maximum height, after which you'd have to deal with a different set of requirements and restrictions. And Danny, do I have that right, or am I overselling it? Because from my understanding,
Let's have Ed, maybe Ed, if you're there, maybe you want to add your 2 cents to it. I see you're in the meeting.
Yeah, height restrictions, it's just one element of the new 2020 building code. Keeping things low to the roof, definitely key in avoiding the solar array being considered an obstacle. If it's being considered an obstacle, different ballast provisions prevail, and the system ends up being either unbuildable or much heavier. So definitely having east-west racking and landscape orientation is a much better option for you if you want to keep those ballast weights low.
Yeah, and if I can add a couple and one more thing on the east-west from my side, and not only is the PSF significantly lower, but you'll see even a bigger difference in the amount of ballast required because you can fit more solar panel and more racking on that roof. Both of those components have weight, which then means that is weight that you don't need to add via ballast stones. And I know every installer loves carrying around ballast on the roof, but there'll just have to be a little bit less of that with
That's my
east-west
favorite
racking.
part.
That's well, I think maybe the installer's girlfriend's favorite part because they get all buff and jacked, but from carrying around ballast. But yeah, it's obviously not what we want to pay people to do, right? It's not the best use of time and money. And this is another significant advantage that people generally are not aware of. Solar panels weigh. What does the 620 weigh? Denai?
Go back to the first slide for this. It's at 33.4 kilos.
Yeah, so that's 1.5 or 2 ballast stones, right? Each panel that that you don't need if you install with east-west racking.
Yeah, like you bring up a good point. I remember when I was working within an EPC as a design, engineer, and sometimes depending on the condition of the roof or the age of the roof or the materials included in its construction, you would have pushback from authority having jurisdictions on the amount of weight that you're trying to put on there. So it always eases their mind a little bit if you can minimize that weight too. So even from a permitting viewpoint.
Yeah. And it's
It can be
much
a good
more
benefit.
balanced out the weight typically with the solar panels now being a major part of the ballast.
Yeah, no, for sure. So those are some of the FAQs that we came up with. Are there any others in the room that we may want to touch with? Well, if you do, you do have a very knowledgeable team, connected to you through Franken Solar. And if you want to see how you can build that system around with Canadian solar modules, we do have a very extensive network in Canada. I mean, the name gives some of that away, but you can reach out to your regional sales manager, who is Sean Liu, and I've provided some information here. I am seeing a question in the chat. So
Number of inverters.
let's see. One issue I found with East-West design versus South was limitation on the number of inverters and MPPTs for a string inverter required. Can you discuss this? I guess that would be more on the inverter side, but yeah, I just want to. I'm not sure.
Yeah, I mean, most inverters these days, and I don't know what you're using, Sean, but what we would recommend is something like a Solis 250 kilowatt inverter. I'm just trying to pull it up here from our online shop. I believe it has like 16 MPPTs or something like that. Ed, do you know on top of your mind how many MPPTs?
I don't. Sorry, Danny.
No worries. I'm just pulling it up here. It has 12 MPPTs. Every MPPT has 2 inputs. So our recommendation would be that you use one string into that MPPT on an east string and 1 MPPT on a west string. Now, does that make sense? No, that doesn't make sense. It would be actually you would want to use the same MPPT for east and west. East. So if you have 2 strings east, put them in 1 MPPT. So use half of your MPPTs on the west, and then half of them on the east on the same inverter. And now you're going to also have less clipping on that inverter than you would with a purely south system where all your power is coming at the same time. Be happy to discuss this with one of our on-staff engineers, Sean, to show you the benefits further, but you actually will have less clipping with the east-west, and you can oversize the inverter even more than with the south-facing.
So what you're saying is that as long as the inputs of the MPPT are balanced, that's the only real
Correct.
thing that we need to account for.
Absolutely, yeah. So
Okay, that makes
it
sense.
should not be an issue at all. And happy to, if you have a specific project you'd like discussed, would be happy to work you through that. Mitch asked about the SL Rack webinar. Happy to have you review that. It's on our YouTube channel. If you go search us Frankensolar on YouTube, you'll find our channel, and all our webinars are on there. Including,
I think that should also answer Asif's question about the tilt angle. I believe these are pretty low tilt, right? These are
yeah,
what,
we do
5?
everything we do is at 10 degrees tilt east-west. 10 degrees is ideal because it allows it, you don't want to go much lower because you don't have the cleaning aspect of rain at 5 degrees as much as you would at 10, and the snow doesn't slide off as nicely. So 10 degrees is the typical tilt.
Good questions. I'm gonna check out the webinar too once I.
Yeah. It's
right
I mean, what we're seeing from Europe, right, where this system was designed, 95% of systems now are east-west, and really the big advantage is, you know, to deny its original point, it's maximizing the roof space, because you can produce significantly more kilowatt hours on a given roof with an east-west. Nicole is asking if we have an example of string drawing. Absolutely, Nicole. Be happy to, if you want to connect with your account manager at Frankensolar, or you can write an email to sales@frankensolar.ca and we'll hook you up with someone. And we do have examples of string drawing, and we can set up a call with Abdul Kader from our engineering team or Alexander to walk you through that. Mitch is asking about 200% AC/DC oversizing, if that's available or authorized by all inverters or inverter manufacturers, and the answer to that is no. It really depends from inverter to inverter manufacturer, as well as the inverter itself. Some inverters, even within this like same manufacturer, will allow for more oversizing than others. It depends on which version sometimes of the inverter it is. So for example, the Solus 185 kilowatt inverter versus the 125 kilowatt inverter, they're the same hardware or very close to the same hardware, and the 125 you're allowed to oversize significantly more than the 185 because of the heat sink size and things like that. Because as you oversize, you create some heat.
I can speak to that with any authority because I'm not on the inverter side, but we do a good amount of compatibility studies. So I've gone through my fair share of data sheets. And what I see is they typically provide a minimum, oversizing percentage. Like most of them don't want to drop below 1.2, 1.25, some 1.5. I don't know that I've seen too many explicit restrictions on how much you can push it, but to Danny's point, you may come across some performance issues, and I do wonder if some of them may have these speculated in their warranty.
It depends,
statements.
Then it depends. Some inverter companies cap it, and then the other thing is, you know, even if it's not capped, you're limited by the amount of input current and input voltage, right? So as Denai, for example, showed, with their panels, you can do 28 panels in a string at a 1500 volt versus another panel where you can only do 26 in a string. And then the Canadian solar panel has more current than some competitors, right? But in any scenario, for example, with the Solus, you're always capped at 2 strings per MPPT. So you're never penalized by how many strings you can put in per MPPT. So going back to the Canadian solar panel, you will be able to put in more panels on that inverter than with the 72 cell panel. So yeah, it really comes down, but be happy to walk you through that and show you what you can do with any given inverter match. Then Asif asked about installation cost compared to traditional south-facing racking. Ed, do you want to answer that?
Sorry, Danny, could you repeat that one?
The question was on installation cost with the SL east-west versus south-facing from another manufacturer.
I think, you're looking at something that's pre-assembled. It's roll formed, it's made specifically in the factory and pre-assembled so that you don't have to do the work on site. Many of the other competitors' products, they come as pieces you need to assemble. And that presents, for larger jobs, a lot of time. Whereas with SL Rack, it snaps together really easily. And there's minimal ballast, so it's less block to have to move around on a rooftop. So those would be the biggest advantages.
They come in like kits, right? From my understanding.
Yeah, it's
correct. So the tilt leg basically folds up and then everything snaps together. You can add maintenance aisles if you need to, if you want to. The designs are really, really well done. We can actually work on designs with you, the installers, as well, to ensure that your client has access for maintenance if they want, or if there's any obstacles, we can make sure we avoid those. It's tailored specifically for each individual rooftop.
yeah.
Oh, and they provide free stamp drawing services as well.
Yeah, it's quite a nice product. One customer that installed, actually one of the first bigger ones in Canada, wasn't east-west. It was 360 kilowatt, and they said it was 4 times faster than the racking that they used previously, which was one of the probably the major Canadian racking company out there. So it is super fast because of all the clicking in and few components. Nicole had a question. Nicole, everything with this racking is in landscape.
Yes.
No jumpers needed. Just make sure that the panels have long leads. Don't go with the short leads, because then you're going to have a nightmare. And then you're going to string them together. All the panels that are facing east are in one string, and then the panels that are facing west are in another string. You don't want to mix them into the same strings.
I'm trying to remember if you guys have stocked the short
no,
or long.
Everything is long leads. Everything we have is long leads. Yes. It's one of the main reasons is because of everything is now, or pretty much everyone is going towards landscape racking anyways in Canada because of the new building code. You're really kind of pushed in that direction, because the further off the roof you get, the higher the wind forces are, the uplift forces are on a racking. And in portrait, you're always going to be higher off the roof than in landscape because the panel is longer. So that's why even some of the other racking products are switching over to landscape now, because the ballast requirements are getting out of hand with the new Canadian Building Code. Any further questions? I'm gonna wrap it up here shortly, but if someone has another question, now would be a good time. Okay, well, thank you, everyone. If you have more questions regarding Canadian Solar or east-west racking or inverters or anything else, please reach out to myself or one of our account managers, or send an email to sales@frankensolar.ca. I'd like to thank again Canadian Solar for helping us out with this presentation. I think we all really are big believers of east-west racking, because at the end of the day, it allows us to sell more solar panels, right? It allows you to install more solar panels on a roof. It allows the building owner to create more solar energy. So I think this is a win-win-win situation for everyone. Yeah, if you have more questions, feel free to again reach out to us. Denai, is this your last webinar of Canadian Solar? Yeah, so
dead last.
The very last one with for Denai, as she's moving back to Europe. So we'll miss you. I appreciate everything you've done over
It's always a small world.
It is.
SL Rack works has a good amount in Europe too. So
yeah,
you never know when you'll see the last of someone. Regardless, it's been a pleasure having my last webinar with you guys. You've always been great partners. And yeah, everyone, if you have any questions on more of the racking and system design part of things, Franken Solar is a great resource. If you have any more module specific questions, you can reach out to Sean Liu or our general sales email for Canada, and someone will get assigned to you and help you out. All right, awesome. Thanks everyone.
Thanks.
Thank you so much, Denai.
Bye.
Thank you so much. Bye-bye.
Thank you.